Okay, good evening, everyone. Thanks for joining us. We're going to start off this evening with our first Hangout on air, with the first topic looking at how to monitor MongoDB. So this is the first of a series of Hangouts that we're going to be running. And joining me this evening is Paul from MongoDB. So the plan is that I'm going to spend about 20 to 25 minutes going through some tips and tricks, things you need to look out for when monitoring MongoDB. And then I'll hand over to Paul to run through some basic best practices, and then we'll open it up for questions and answers. If you have any questions, then you can sign in and put them up through Google+, and they'll appear for us and we can answer them towards the end. So I'm going to get going and start the screen sharing session. Okay, so let's go. So this topic is monitoring MongoDB, and one of the most important things you need to do, I suppose, in production is to know exactly what's going on. So my name is David Mitten. I'm the founder of Server Density. We do website and server performance monitoring. We look at the availability and response times of your public services from locations around the world. We look at the internals of your servers, so you can correlate the two, and then provide you with alerting, graphing, and dashboards on top of that. And one of the reasons that we picked MongoDB as the first one to look at is that Server Density is powered entirely by Mongo. We have about 100 servers across 2 data centers, and we're running Ubuntu Linux exclusively. It's about a 50-50 split between virtual and dedicated, and we're processing about 200 terabytes of data per month through Mongo. And the tech stack that we use is primarily Python connecting up to MongoDB with Nginx as the front end. And we're hosted on SoftLayer, and our largest MongoDB cluster has about a terabyte of RAM and over 5 terabytes of SSDs powering it. So the key metrics that we're looking for when we're monitoring MongoDB, and there's a lot of different metrics that you can be looking at, but there's kind of 4 main ones that I picked out as the key metrics that we look at and the kind of things that you should also be paying attention to. So the first of these is Oplog replication lag, replica state if you're using replication, the lock percentage, because MongoDB is locking on a database level, and then disk I/O. So it sounds like you can't see the slides, so let's just check, see what's going on. There we go. Let's not use presenter mode. So the server density architecture, as I just went through, and then the key metrics that we've got there. So we're going to look through each of these metrics to kind of understand what they mean and what you should be looking for. So the first one is to do with the Oplog replication lag. And this really applies when you're using replica sets. And the way that this works in MongoDB is as a master-slave setup. You have a single primary that accepts all the writes, and generally accepts all the reads until you start configuring the slaves to also help you if you need to scale out and accept the reads there. And the way the replication works on MongoDB is asynchronously. So all the writes hit that master, and then they cascade down onto the slaves, which means it's eventually consistent. And you start configuring this by tweaking what's known as the write concern. And this allows you to control the behavior. So you can use the default, so it is eventually consistent, where data is cascading down to those slaves, but it can be tweaked depending on the configuration that you need, depending on the query, the collection, the database, or even on the server level. And this is done on a driver level. And you specify the write concern when you are issuing write commands. And by default, this is set to 1, And it means that you're going to get an acknowledgement from the primary master server that the write has been accepted to be written to that server. But as you increase this, then it allows you to tweak that so that the data will only return, or the command will only return, once it has been replicated to multiple slaves. And this allows you to really configure and be very flexible around exactly where your data is going to be and getting an acknowledgement of that. So if we go up to replication level of 2, then you're going to be guaranteed that the data is written to the primary and then has gone down onto the secondary as well. And this can be configured across multiple data centers. You can configure on tag levels and within the configuration for the replica set itself. This obviously has a trade-off. So during our own testing, we were able to see that as you increase that write concern, as you expect, then the performance decreases. This is obviously because you've got to send the data across the network to another MongoDB instance or multiple instances and wait for that to acknowledge the write. So it's really a trade-off between performance with the lower write concern and the durability of the data, or at least knowing that it's gone to end slaves. And so coming back to the Oplog replication itself, it's really important to know when your slaves are starting to fall behind the master. There are a couple of reasons why this might happen, and you need to keep an eye on it so that in an event of a failover, the data that you're expecting actually exists on those slaves. Because there's a time between when the data is written to the primary and when it is synced to the slaves, then if there's a failover in that period, then you could experience the fact that the data is missing if you have to fail over to one of the slaves before that data has appeared there. There are a couple of reasons why this might happen. The most common is network congestion. Networking problems meaning that you can't, the data just can't reach your slaves. This is more likely to be a problem if you're replicating over the internet or over longer distances between data centers, or there could be issues on the networking infrastructure itself. You also might have hardware problems. So if there's a disk failure, or if you're rebuilding a RAID array on one of your slaves, for example, or if there's a performance problem, some kind of hardware failure on those slaves, then just receiving that data could start to slow down. We've also seen this replication lag with shard chunk migrations. And this, by default, generally can't happen because the chunk migration will wait for the slaves to catch up. But depending on your configuration options, you can disable that so that you can speed up the chunk migrations. But that's at the cost of your slaves perhaps being behind whilst they also catch up with those operations. And it's also possible, although less likely as Mongo's QA gets better and releases happen, that you possibly hit a MongoDB bug, which could cause a slave to hang on a particular update or some other problem there. Most likely you're going to hit the first three, and if you haven't disabled the secondary wait, then probably networking or hardware is going to be the problem. So this is all reported in the tools that are going to go through shortly. It's the uptime metric that shows when looking at the replica state. And as this starts to deviate from the current real time, then that will show that your replication is falling behind. So the next thing to be monitoring out of the 4 key metrics is the replica state itself. And this is really which servers are primary and which are secondary. Generally, it's more of an informational metric. In most cases, Mongo will handle the failover itself. It will detect that there's a failure within the replica set and automatically trigger an election and then decide which of the other servers is going to become primary. Usually this can happen without any kind of human intervention, and so it's more of an informational alert. However, this should be rare. You shouldn't really be seeing these kind of failovers often in production, which is why we consider it a critical alert. Although Mongo will be able to recover itself, we might see a temporary increase in our error percentages as the drivers recover. We want to investigate that problem as quickly as possible. It could indicate that there was a hardware issue on the old primary, or there's some kind of ongoing network incident, and so we want to investigate it wherever possible. So it's important to alert on this state change. As I said, in most of the situations that we've seen, Mongo is able to fail over very, very quickly with almost no impact to customers and to clients. And if you construct your driver queries correctly, then you can simply retry whatever query it is. It might manifest as a slight delay to the end user, but all the drivers handle this through exceptions and errors, which you can catch within your code. So the next of the four metrics, the third one is the lock percentage. Now, in Mongo 2.6, the locking granularity is down on the database level. This is going to be improving in future releases, but it's something that needs to be considered because it sometimes comes up as a problem. As lock percentage increases, then you're really hitting the hardware limits of the individual server. And so the first step is to increase the hardware capacity. Often this will be switching in SSDs, but in many cases it's simply that you're just sending too many queries to that particular server, too many write operations, and so the only realistic way you can scale this out is by moving to sharding. This becomes a problem as you near 100%, or if the value is constantly high. The main symptom of this is slow queries and slow replication. If locking is high, then your MongoDB is waiting for server resources to be able to service any queries. But once you hit 100%, then it's really too late. So you need to be monitoring this on a constant basis. This is because as you start to reach the limits, then you're going to need some capacity to move data off. Remember, if you're going from 2 shards to 3 shards, then you're going to be migrating a substantial proportion of your data. This decreases as you have more shards, simply because it's distributed across more servers. But it still means that as you add a new shard into the cluster, it's going to have to rebalance. And there's going to need to be capacity to do that. So the general metric that we alert on for this on a non-critical basis is around 70%. And this will give us enough time to monitor in more detail, to figure out what the trend is, and to put in place a plan to increase capacity over the next few weeks or months. Now, linked to this is the disk I/O percentage utilization, and this is more specific to the hardware. Again, as you're reaching 100%, then that is hitting the limits of the physical disks themselves. And if you're seeing constant high percentages on this, then that is really the time to start thinking about upgrading your disks. Again, the same kind of numbers apply, going from about 70% as a non-critical warning level up to 100% as essentially hitting the limits of that disk. And this is really the physical limits of how many writes that the hardware can physically service. So the first step is to go from spinning disks to SSDs if you're not already on SSDs. The general rule of thumb is that you should put have as much RAM as is equal to the index size. So all of your indexes go into memory, and where possible, all of your data in memory. But that's not necessarily feasible if you have huge data sets, because memory is obviously very expensive. So the next level down is the disk. And Mongo is going to have to read from disk at some point, whether this is the journal or the Replica Oplog, or even if you're starting up a new server cold and need to bring it online, Mongo's going to have to read the data off the disk. And so the best way to do this is to give it SSDs. SSDs aren't cheap, but they are cheaper than RAM, and they give a significant performance improvement. This graph is quite small, but if you go to our blog at blog.serverdensity.com and search for MongoDB SSDs, then you'll be able to see this graph and the metrics that we benchmarked when looking into what the performance improvements were from switching from even 15K SAS drives down to SSDs. And when it comes to the performance of the journal, comparing spinning disk to SSDs, then SSDs are 3 times faster. And this is a great way to get more performance out of your individual hardware without necessarily having to order more instances or more physical hardware, or to go to sharding if you really want to push it that far. Going to SSDs is a great step. Now, there are quite a few symptoms of this, and the main ones being slow queries. And you can often see that you'll have random hangs of queries because the disk will hit 100% and the queues will start to back up on Mongo as operations queue up, waiting for the resources that are at 100%. Again, another symptom is slow replication, but the main one you'll see is slow queries and hangs. And these will start to show up to your users, but also they'll be logged within the Mongo log. And you can tweak the settings for what is considered a slow query so that they start getting logged, enable the profiler and see what's going on. And often you won't be able to see an easy pattern if you've got all your indexes all set up correctly. So you have to switch over to the IOstat tool on Linux to have a look and see what the percentage utilization is. So after you've kept an eye on those 4 key metrics, there are a few non-critical metrics to watch as well. These are important for kind of capacity planning and understanding what your cluster is doing over time. We don't alert on these on a critical sense, but we monitor them so we can look at the trends on the graphs and be aware as our cluster usage is growing. And the first of these is memory usage, and in particular page faults. Well, page faults are where Mongo is having to go to disk to find, to service whatever query it is executing. In all cases, we want to try and get Mongo to service everything from memory. And as the server warms up from a cold boot, this will become more and more likely as data is paged into memory and becomes available. And Mongo is pretty good at moving things around to make sure the most commonly accessed data is available in memory. But if you don't have sufficient RAM to cover all of your data, then at some point Mongo is going to have to read from disk. And these are the page faults. It's also a good idea to keep an eye on the number of connections. Every connection to Mongo has an overhead, and this adds up to the amount of memory you need to provision for the server. This was originally quite high, but in the later versions of Mongo, it has been much more optimized, but it still has that overhead. There are particular problems if you're recycling connections a lot. So if you're doing a lot of opening and closing of connections, then the overhead of having to actually initialize that connection in the first place is going to have an overhead for your drivers. And shard chunk distribution is also important to monitor. There's often an assumption that you can enable sharding and just let Mongo deal with moving the data around. And for the most part, that's exactly what it does. But there are cases where it can start falling behind if it's hitting hardware limits, or there are problems with the sharding key itself. Then Mongo might be unable to distribute the shard chunks fast enough and evenly. And so it's important to know when your cluster is becoming unbalanced. This can indicate that you don't have sufficient hardware capacity, or there's a problem with the shard key that needs investigating because data gets setting up as hotspots throughout the cluster. We have a script that we've released which helps you do this. In a minute, I'll show you the Mongo command line, which allows you to check it. But the script is also useful because it allows you to very quickly get an answer to yes or no to whether your Mongo shard is balanced or not. And this can also be plugged into a monitoring system and can be run programmatically, whether that's through server density or through any other custom system. The script's fairly agnostic. So all these metrics can be monitored using a couple of monitoring tools and command line options which are provided by Mongo out of the box. The first of these is MongoStat. And I'm going to quickly log into one of the servers so you can actually see this. I should be able to share my screen on this. 1 second. Okay. So MongoStat is run against MongoD or MongoS. It's more useful against the MongoD because you can see exactly what's going on an individual shard or an individual server there. And it executes pretty much every second and gives you a real-time view of exactly what's happening on that particular server. You've got the op counters, number of inserts and queries that are happening, the commands. You can also see the page faults in real time and which databases are locked. One of the really useful columns here is the queued readers and queued writes column, which is towards the right here. And this is useful to watch if you're seeing hangs or major performance problems in production. Then you can see this queues column start to increase as Mongo is waiting for resources to be able to service those queries. And this is often seen in tandem with increase in the number of connections, because as queries are queued up, then the number of connections will increase just because your drivers are trying to open more connections and get access to the database. It's also useful to be able to quickly spot which of your replica set members are in which state. Now here I'm just connected to a single MongoD, which is the primary, but if you provide on the command line the list of your servers, then you can also see whether they're secondaries or arbiters. And so if you want to log in very quickly to see the state of a particular cluster, you can see that in real time as they all update. And the next tool is MongoTop. Again, this connects to just a MongoD in this case, and it's a good debugging tool to be able to see where Mongo is spending its time. Now, for this particular cluster, the majority of the operations are write operations, and we have only 2 databases and just a single collection within each database. So it's not as interesting as if you had a much larger database with a large number of collections or multiple databases. But the point here is that we can see where Mongo is spending most of its time and how much time it's spending. And it allows you to pick out those hot databases and hot collections so you can optimize them further, and whether that's going into the indexes, splitting things out into multiple databases, perhaps sharding within the collections, or you could even be mounting those databases onto dedicated hardware. Mongo has a directories per DB option, which allows you to split out the databases into different directories. And that will then allow you to put those databases onto different mount points and optimize what hardware is on the underlying mount points. So for example, you could put the journal onto an SSD and a very hot database onto an SSD as well. But perhaps an archive database could just go onto a spinning disk because it's a lot cheaper. So make sure you can see the slides there. Yep, good. Okay, so the other 2 tools are command line tools, which are executed either from the Mongo shell against the MongoS or against the MongoD, depending on what it is you're querying. Now, the rs.status command is run against MongoD. It can be run on any of the MongoDs in a replica set, and it shows you the status of that replica set as seen from the member that you execute the command on. This is useful to see what that member is seeing. So if you have a network split or some other problem where that particular member can only see a subset of your servers, you can see exactly what it's able to view. You can see the state of all those servers, and you can go into the uptime date to see how far behind the slaves are from the primary. So in this example, it's 1 second behind. You can also see how many milliseconds it is between each instance. That increases obviously as you go over multiple data centers. The status command for the sharding is run against the MongoS. This allows you to see a basic state of the sharded cluster. It lists all the shards and, importantly, the number of chunks on each shard. This is how you manually check to see if you have a balanced cluster. And Mongo runs the balancer to move chunks around to try and keep the chunks fairly even. And this is the command that is run by the Mongo balancer test script from earlier. So those are tools that you can use to run those commands manually in real time, but it's something that you can't really do 24 hours a day. And this is where monitoring tools come in. And obviously, server density can do this for you. We can connect to each of your MongoDs and the MongoS and pull out all these stats, graph them, and trigger alerts. You can also use the Mongo MMS service, which is provided for free to give you monitoring. And Paul's going to go through a little bit about that shortly. One of my favorite views on this is the sharding overview, which allows you to see very quickly the state of your entire cluster. MMS is entirely focused just on Mongo, and so it works well in conjunction with server density, which gives you a very good overview of your entire hardware setup and availability, rather than just Mongo metrics. So in summary, you need to have those critical alerts on the key metrics. That's the Oplog replication lag, because if you're relying on those slaves in a failover situation, you want to make sure they're as up to date as possible. Replica state is important to monitor, not really because you have to do anything to allow Mongo to recover, but more that you want to know why it has failed over. Lock percentage and disk I/O percentage utilization go hand in hand. The lock percentage looking very specifically at Mongo itself and the internals of Mongo, whether you're reaching the limits of an individual Mongo server, and whether you should do any optimizations by moving data around or setting up with sharding. And then linked to that is the capabilities of the disk itself on each individual server. And with both metrics, as you get to 70%, that's kind of the key non-critical warning level, with 100% being too late and is where you've hit the limits. But it's not just those key metrics. Those are the ones you want to be woken up when there's a problem, but you should also be watching those non-critical metrics, things like memory usage and connections, and also your shard distribution, because whilst they won't cause an immediate problem, they're more likely to escalate into a critical issue later on. The manual tools such as MongoStat and MongoTop are useful for real-time debugging, and you can look in development as you're tweaking your queries, how it affects a MongoD, and when you're in production, it helps you troubleshoot situations as they arise. But they're only useful really if you need to look at a very particular point in time. You really should be setting up a monitoring product to query these at a regular interval so that you can have graphs to go back and look at to help you plan capacity, but also trigger those alerts. And both MMS and server density used in conjunction are great products, but there are also a range of open source tools. So if you go to the MongoDB documentation, there's a list of plugins for the likes of Nagios and Cacti to help you build these graphs yourselves. And a lot of the topics that I've gone through today are covered in the blog post, Monitor MongoDB, which is on blog.serverdensity.com. So I think that's it from me. I'm going to hand over to Paul now, and he's going to go through a few other things.
Can you hear me, David, and see my slides?
Yes, yeah.
Hi, everyone. So yeah, I've just got 3 slides to really add to what David talked about there, and then we can get to the Q&A, which is probably the most important part. So I'm Paul Down, a solution architect for MongoDB in the UK. And I thought, first of all, I'd just share my quick and dirty cheat sheet, you know, in the moment when you need to just get on a server and check a few things. So as I've implied here, this really isn't a replacement for having constant monitoring in place that's building a historic view and showing you that trend over time. And that's really what you need in place, something like server density, ideally. But sometimes if you just need to get on a box and see how the database is doing, and I'm sure some of you out there have got similar cheat sheets yourself, so maybe if this is useful to you, hit screenshot, print screenshot now, and you've got a copy of this, or email me afterwards. But a lot of them are obvious. So, for example, you might log onto the shell and quickly get a feel of how the database server is doing itself by DB server status, and then go and have a look at your collections and the size and the stats on them and the index size, the padding factor, and things like that, and just get a sense of how your MongoDB daemon's doing, your databases and your collections as a quick sanity check. In the middle here, I guess I've shown some command line commands you might run in the bash shell, for example, on your Linux host. David talked about MongoStat before, extremely useful. If you're running a sharded or replicated environment, you might want to run it with the discover flag here, and that will actually go off and find all the different MongoDBs in your cluster and show the stats for each of those. But often, maybe when you're doing, you're looking at performance, trying to find the bottleneck in real time, you might run MongoStat to see how the database is doing, and then top. I know it's an obvious one, but if you press, if you run top and then press the key 1, it will actually show you what each of the cores are doing on each of the processor cores, and then running those two alongside IOStat to see how your hard drive's doing and the disk utilization. And it's often useful to see those three things at the same time when you're looking at performance problems. But again, there's no replacement really to be able to see a graphical and trended view over time with something like server density or MMS. Finally, again, if many of you might be familiar with this already, but you might be having a particular bottleneck or performance issues with a particular database and a particular collection, for example, or set of operations. So there's some command line options you can run in the shell here to try and see what's happening on your specific database collection. So I've given an example of here how to turn that on, and then show for mydb.mycollection, my col, the last 3 operations, what's been happening in those. Did they hit indexes or not? What was the query plan and the like? So it may or may not be useful. Many of you might be doing this already. And as I said before, the thing about this is it shows you what's happening in the moment right now, but it won't show you what's happening over time or historically, which is key to things like server density and MMS. So as David alluded to, MongoDB has something called a MongoDB management service. Monitoring is just part of that, and it only really gives you the view of what MongoDB database itself is doing. With something like server density, you would get the holistic end-to-end view of what your application tier is doing, your web tier, the underlying operating systems and the like. But sometimes it's useful to use both of these alongside each other. I guess the bigger things going forward with MMS from MongoDB are around automation, which is coming soon. The ability to provision to bare metal or a virtual environment a new MongoDB cluster that might be replicated, it might be sharded, and then the ability to do rolling updates of maybe patches for security or bug fixes, and do that in a rolling fashion where you don't have any downtime on your database and your applications and your drivers don't see any downtime. So that's coming soon, and that's going to be a big part of the management service. And then lastly, something that's available now, and I know server density guys and David are using this themselves to back up their environment, is the continuous backup and point-in-time recovery capability. And essentially what happens is MMS pretends it's another replica listening to the Oplog of your primary in your replica set and keeps on recording all the operations. And then it gives you the ability to say, actually, if, I don't know, a DBA came along and dropped a collection inadvertently, or your application tried to do a delete and it built a where clause wrongly and deleted too many records, and maybe that happened at 3:41 in the afternoon, you could come along and say, actually, I want to restore to the point of 3:40 in the afternoon, just before that problem occurred, and I can get my database back up to a good state. So it's not just about, say, having replicas in place to security to go back in time. And so that's becoming very key to some of our customers. But there are other options. You know, you can use MongoDump, and plenty of you guys probably are, where maybe every night you run that tool to dump out your database, and then you can restore it. Or maybe using file system snapshotting or SAN snapshotting capability. So MMS backup is another option there, but it gives you the ability, there's some benefits of giving you that point-in-time recovery. And in a sharded environment, it enables you to be able to restore those shards in a consistent manner, where each shard on a different machine has to be recovered to the exact point in time, which is pretty difficult to achieve with other technologies. So perhaps something to look at alongside the other features of MS and server density. I think that's it for what I was going to say. I don't know, David, do you want to go to QA? We got a hand back.
Okay. So if you have a question, then you can sign in and you can post the question up, and we'll be able to see this here. So Paul, I think there's a question there for you.
So you might have to read it out to me, because during the whole session I've not been able to see any questions or faces. So
okay. No problem. So the question is, how soon is soon for the automation?
Yeah, it's been, we've announced it publicly, so it's not one of those things we're not supposed to talk about. It's been in a long beta phase with some customers, and for good reason, because it's one of the, especially when we do those rolling updates across the sharding environment, to get that wrong could be, catastrophic for a customer. So it's in prolonged beta at the moment. I think we've committed for that to be released by the end of this calendar year, and what I'm hearing is that's still the case. As always, it's hard to give an exact date in a future-looking sense without breaking some rules somewhere or another, but I expect by the end of this calendar year that will be in place, if not earlier.
Excellent. So at Server Density, we're using MMS for the monitoring. It's very useful as we have a support contract to be able to have the engineers on MongoDB's side just have all the stats they need. But as you said, Paul, we're also using the MMS backup, and we're backing up about 2 terabytes of data size. But because we're storing multiple snapshots, then actually it's probably around 8 or 9 terabytes of data actually being stored within MMS backup at any one time. So does anyone have any other questions or anything you want to go through? Doesn't look like there's any other questions. So I'm presenting at the All Your Base conference that's coming up in October, 17th of October, here in the UK in Oxford. There is another question that's come up regarding how deployment works on Google Cloud. There's a comment that it feels like it's just a one-time setup, so they're quite keen for the automation. Paul, is there anything you want to say about how that works?
Yeah, I guess at the moment, currently with what's full released versions, we're really, when we look at cloud-based services, whether it's from Amazon or Azure or Google, it's really sort of what I would call an IaaS plus capability at the moment. Maybe optimized images of MongoDB for that particular cloud environment and set of best practices. What we're really doing with automation is trying to take it up to that next level of almost PaaS, platform as a service, or database as a service. Probably, depending on your definition, not quite, not necessarily self-provisioning at that point, but really we see automation as taking it to that next level. I guess the other thing to say about automation is it doesn't necessarily have to be virtual machines or cloud-based environment. You can actually use it for provisioning onto a set of bare metal machines you have. It's just in that case you will have to ensure those machines have a small agent running first of all to bootstrap it, sort of a chicken and egg situation really. But actually, David, just while I remember, it might not be the right time, but a slight advert from me as well. We had MongoDB World about a month ago, which was quite successful in New York, and now MongoDB is doing some city tours, and we've got MongoDB in London, and I'm struggling to remember the date now, mid-November, but if people search for MongoDB London mid-November, I'm speaking there and various other people are. I'm not sure, David, whether you're going to make it over there, but that should be a good session for people that are UK-based.
Yeah, definitely. I think there's you're running them around the world as well. There's a range of different cities that are usually on the MongoDB tour.
Yeah.
Yeah. So in terms of deployment, we use Puppet to handle all our deployment, but the management side of it is where the automation from MMS is going to be interesting. because it doesn't really, using Puppet doesn't handle the fact that you've got to do rolling upgrades easily, and being able to do the rollback is also tricky.
Yeah.
It's obviously possible, but it's nicer to have a button to press in MMS to do that.
Yeah.
I know a lot of people use Chef as well to provision things. So the scripts and things that are built out already available, but I think what's coming from MMS automation will be particularly interesting. Okay, are there any other questions that anyone would like to answer? So this has been recorded, so it will be available on our YouTube channel, and also we'll post up on the blog, so blog.serverdensity.com. The next Hangout on Air that we're running is on Nginx, which will cover very similar topics, and we'll have one of the engineers from Nginx to come and help present some tips and tricks for monitoring. So if you check out the Server Density Google Plus page, then you'll be able to sign up for that. Someone has just posted up that MongoDB London is on November 6th.
Thanks, guys.
Okay. So I think that's it. Sorry for the technical issue at the very beginning. This is the first Hangout on Air that we've done. It's not entirely straightforward. If you have any other questions, then feel free to send an email to david@serverdensity.com or paul.dunn@mongodb.com. Thanks a lot for everyone. Good night.
Thanks. Bye.